Alright, I'm live, I guess. Okay, study stream. I've actually never streamed on YouTube before, so we'll see how this goes. I don't think you can see that. It's probably inverse, but we're doing physics. That's the goal. I have a physics test tomorrow. We're gonna study for it. It's gonna be a boring stream. I highly doubt anyone will join it, but if they do, I apologize because it's not gonna be fun. So yeah, I'm just gonna study. I'm making these videos because I want to look back on it one day. I think it'd be kind of fun. I could record it, but I feel like streaming it, I think it just like directly uploads after I finish, and I don't want to upload like a potentially 2-3 hour video. That would take a long time. So we'll just try this, see how it goes. I'm gonna play some music. We're gonna see if it works. Yeah, it should be fine. I don't know. I guess we'll find out if I get a copy strike. But I probably won't because I'm not a very big channel. Nor do I make money. So let's have that playing in the background while I study. Okay. Try I like these questions because they don't really do anything. Alright, we'll try it. We'll start. There's gotta be something here. Okay, we'll try 4. Let's start with 4. Page 54. Question 4. Hopefully that goes well. Look something up. Okay, alright, so let's go in here. Alright, speed. Increasing with 10 meters a second, 10 meters a second, 2 seconds. Okay, what is the average acceleration? Okay, so formula sheet. Okay. So, for accelerating, the acceleration formula. So we have A, its velocity. So it's going to be v2 minus v1. So v2 minus v1 over our time. So we have 20 meters a second minus 10 meters a second divided by 2 seconds should give us our answer. Oops, what has happened to my calculator? I don't know how this happens. I don't know what I pressed, but I messed my calculator up. Google this. What I did. How do I turn off SX? I have to watch a YouTube video. Watching YouTube videos on stream. This is good content. What is this video? This is... Maybe this is what I need. Holy fuck, my calculator. What did I do? This is terrible. What? What? I'm sorry? What is this? It's in SciMath mode, which makes me think maybe it needs to be... Nope. How do I turn that off? I don't want slime. I don't believe I want... Don't fix. Okay, now it's in fix, but I guess I don't want to fix. Maybe I want more. It's not more. Maybe I want... Nope. I really don't know what to do. Hmm. This is more perplexing than the fucking math. Wow. This sucks. I broke my calculator. What the fuck? Oh, maybe off? No. I might just be remembering this. Display? No. What's one? Nope. Nope. Reoccur decimal off. That's fine. I want. I tried all of these, I think. What? Oh my god, I didn't even change the brightness of a calculator. What? Since why? Why? What? That's kind of cool. That's funny. I don't know why I can do that, but you can. Okay, I like that brightness. Please work. My god. Cut off is horizontal. Rad. No. We want degree. Maybe we want science. Hmm. I cleared the memory, but it didn't do what I wanted it to do. Clear setup? Sure. Please work. Did I fix it? Okay. I think it's fixed. Alright. Well, it's good. That means I can actually do work now. So 10 divided by 2 is 5. Is that the answer? Yes. No. It doesn't tell me the answers here. Oh, it's a multiple choice. Yeah, so it's 5 meters a second squared. Okay. Let's do question. There's no. Okay, there's one part. Let's do question 6 or 5. What's 5? The motion of a projectile is described in a coordinate system at a particular instant. The magnitude of the horizontal component is velocity. The velocity is 5 meters a second, and the magnitude of the vertical component of the velocity is 8 meters a second. Which is correct with the object? The projectile is at max height. The projectile is about to hit the ground. The projectile is ascending. The projectile has hit the ground. That's interesting. So I feel like because we've done questions like this, but I feel like you wouldn't usually use it to describe where the object is. I mean, it's not max height because I think the vertical velocity would be 0. Is it ascending? Like I don't know how you could tell that. I can only guess it's descending, but I really don't know. Whatever. We'll do number 6. A river flows with velocity 8 meters a second north relative to the bank. A boat travels with the velocity of 6 meters a second east relative to the water. What is the magnitude of the velocity of the boat relative to the bank? Okay, so we'll draw a little picture, I suppose. The river flows. So the river's flowing this way, and it's going 8 meters a second north. It's relative to the bank. The boat travels with a velocity of 6. It's going east. Oops. So the boat, that's my boat, looks fine. It's going this way. And it's going at 6 meters a second east. So 6 meters a second east. Very simple question. All you have to do is make one direction positive, which will be north. And then it's simply just a subtraction game. 8 meters a second, subtract 6 meters a second will give us 2 meters a second. And that should be it. Oh no, what have I done? I'm stupid. Wow. It's going east, not south. I put it in the south quadrant for some reason. I don't know why I did that. It's going east. So it's going this way. So it's going this way at 6 meters a second west. Okay. Fuck. No, east. I'm actually losing my mind. Okay, so it's going east. And so now it's a little more difficult. I calculate the hypotenuse of this, so it shouldn't be, actually it's not that difficult at all. X or 8 squared plus 6 squared is going to equal 8, 64, and then 36, so 100, and square root it. You get 10, so 10 meters a second is the hypotenuse, which means that's where it's traveling. That's one of the answers, so I can only assume it's correct. Moving on. Okay, indicate whether each statement is true or false. If you think the statement is false, you're ready to make it true. Speed is always a positive quantity or 0, but negative. Whoa. Okay, that's not right. Never negative. Yeah, it seems. Speed can be 0 or positive, but it's never negative. Yeah, so that'd be true. You can't go back in time. Average speed is the sum of all the instantaneous speeds. Actually, you can have negative speed. What am I talking about? I was thinking about time. If you're going, I guess, technically, if you're decelerating, or if you're going, yeah, if you're decelerating, that would be considered a negative speed in whatever direction you're going. Or it could be positive in the opposite direction. So I would say that speed, yes, it can be negative, which makes this statement false. Average speed is the sum of all instantaneous speeds. Is this true? I mean, if it's average, then it wouldn't be the sum, right? It'd be the sum divided by however many speeds there are. So I'm just gonna assume it's false. I'm not gonna read these questions. True or false? It's bullshit. We'll move on. Write a short answer to each question. I'm not doing that. Where's the math? Give me the hard math. Discuss whether an object. Okay, so I guess this question says, can an object have an acceleration without speeding up or slowing down? I don't think it can. I'm pretty sure, because acceleration means there's an increase in the speed. The speed is gradually increasing over a period of time. There's no way it can just... There's no way an object can not speed up or slow down and be considered acceleration. That would just be simply speed. If it was staying at a constant velocity, I think you would just call it its speed, right? I don't know. I think that's right. We'll move on. Table 1 shows accommodations of values and corresponding signs for the velocity and acceleration of the object in one dimension. Give an example of each situation in the table. Okay. I think they want me to draw this. I can probably figure that out. So if we are accelerating, oops. So we have a positive velocity and we're accelerating. Acceleration means it would go like kind of like this shape. Okay, yeah, so let's do it really quickly. It's positive, so it's going up. It should be like that. Well, never mind. I'm supposed to give an example. Okay, so a positive acceleration, I guess like you're at a stoplight and then it turns green. You would accelerate and be positive because you're going forward, I guess. Okay, next one, positive velocity but negative acceleration. Okay, I think if you were just driving, you would be at a velocity, and if you started slowing down, you'd be at a negative acceleration. Now we have, the next one is positive velocity, acceleration is 0. I think this means you're just going at a constant speed. You're not moving up, you're not speeding up or slowing down, but your velocity is positive, meaning I guess you're going in a forward direction. I think that's what that would mean. So, yeah, I think you're just constant velocity. Could be wrong, but that's what I think. Oops. Compare the position time graphs of velocity time graph. For an object in uniform motion, include a simple diagram of each. I'm not going to do that. These questions suck. All of these suck. You throw a ball vertically upward and it falls back to your hand. Identify the points where the instantaneous velocity is the same as the average velocity. I don't know where that would be. I don't feel like I had learned that. Maybe I could guess it, maybe I could figure it out, but I'm just going to move on. I don't have much time. Discuss what conditions are needed for 3 placement vectors to have a vector sum of 0. What are these questions? I just want, like, where is this? What are these questions? Give me that. There's no numbers in any of these questions. Okay, what we can do here. You start 1.5 meters from a reference point, walk at a constant speed for 5 seconds, stay at the position for 1 second, and finally walk back with the same speed as earlier. For the next 3 seconds, earlier, the next 2 seconds. Okay, the draw position time graph. So we don't actually know what direction we're going in, I don't think, so we'll just make this the reference point. So we go this way for 1.5 meters. We walk at a constant speed for 5 seconds. So for those 1.5 meters, we have walked at a constant speed of 5 seconds, or whatever, for 5 seconds. At this position stay at this position for 1 second. So we stay here for 1 second. And finally walk back the same speed as earlier for the next 3 seconds. So then we'd walk. So if it took us 5 seconds to get from here to here, and then 1.5 meters, and then it took us 3 seconds, we're probably going to get around half here, so probably like this. Good enough for me. Use colors in this one. use concepts from this chapter to explain how a juggler is able to juggle balls with perfect timing. Brother, I don't know. Where's the math? Give me the math. Okay, perfect. This is a math question. I can actually do something that's hopefully. 38. A squirrel drops a nut from the top of a tree, and the nut falls to the ground. It takes 2 seconds for the nut to reach the ground. Calculate the height of the squirrel and above the ground. Above the ground, sorry. Okay. So all we have is time. Okay, so I think we have time, 2 seconds, and I think the variable that we're not given, which we should know, is gravity. Gravity is an acceleration. It's negative 9.8 meters a second. So a tree or the nut takes 2 seconds to fall down, and it's at a acceleration of negative 9.8 meters a second square. Okay, so there's our acceleration. Now I think we want to find the distance. I can't find the distance without knowing its velocity, so I'm gonna do my best. We're gonna take our velocity. We'll take 9.8, or our acceleration. It'll be equal to v over time, over 2 seconds. We're gonna isolate for v. So we're gonna have 9.8 times 2. It's gonna equal v. So 9.8 times 2, we get 19.6 meters a second, which equals that. So then we have that. And yeah, okay, so now we're going to have our new velocity, so 19.6 meters a second. It's going to equal our displacement, which is what we're looking for, over our time of 2 seconds. We're going to isolate. Wait, is it over? Surely not. Oh shit, it is. We can't multiply it. Something has to be with the answer. I don't actually know the answer. Okay, so this could be right. I'm gonna check the answer. I gotta find the answer somewhere, but it should be. I think it should be this in theory. Meters equals the displacement. Let me see if I can find the answer somewhere. I don't know what this bullshit is. These are answers I need. Is there even answers in this? I think. Let's review. Okay, these are answers. So we're on page 54. I lost the answers. Okay, page 54 review. Okay, and now we're on question 38. 2.0 times 10 to the 1. So that means it's 20 meters. I have 39 meters. So I've done something wrong. What have I done wrong? 38. Did I look at 38? I did, right? That's 37. Okay, it takes 2 seconds for the squirrel to hit the bottom. Maybe it's v2 minus v1. v2 would be, well, that would have to be v2. Maybe we can use a kinematic equation actually, because we're looking for distance. I think the initial velocity would be 0. Let's try this equation and see if this works. So we have 0 times 2 plus, this will be negative 4.9, and then it will be times 2 squared. So 0 times 2 is 0, so we're really just looking at negative. We're looking at 2 times 2, so 4. So negative 4.9 times 2, which is negative 9.8, or 4, sorry. 19.6, negative 19.6. It's close. I mean, you technically would round up to 20 other displacement. We'll roll with that. Let's say it's 19.6 because it's not going to be negative. And, well, it could be negative, I think. So in meters. And we'll round it to 20 meters. That'll be our answer. Okay. Great question. Okay, an athlete is running at a constant speed of 9 millimeters a second. He takes 3 seconds to come to a stop after he crosses the finish line. Calculate his average acceleration from when he crosses the finish line to when he stops. Okay. Time equals 3 seconds. Velocity equals 9 meters a second. We want acceleration. So we're probably gonna want a negative number, I assume. Okay. We have velocity, we have time. I feel like it's not as easy as this seems, but we're going to try. Just simply do 9 divided by 3. I feel like it can't be this, but who knows? Let's take a look. See how we did. Oh, okay, it literally is that. It's that simple. I should put the angle, or not the angle, the direction. Okay. Sometimes physics is really easy, sometimes it's really hard. I guess it just depends on how they feel. The physics gods. How much they want to torture me today. Alright. At the start of a 100-meter race, a sprinter increases her speed to 9 meters a second in 2 seconds. Okay, there's A and B. What is the acceleration of the sprinter during the first 2 seconds? During the first 2 seconds, okay. That should just be another simple A equals 9 divided by 2. 4.5, so A equals 4.5 meters a second square. And then calculate the time taken by the race. From this point, she runs the rest of the race with the same speed. Calculate the time to reach the finish line. Okay, so she's running at this speed, or this speed. So she's running at 9 meters a second, and she runs that for 100 meters, and we want to find the time. So It's going to be speed formula, which is v equals displacement over time. We have our velocity, which is 9 meters a second, equals our displacement, which is 100, over our time. So it should, this goes over there and that comes, so it should be 100 meters divided by 9, like this, I think, unless I did that wrong. Which would be 11.1 seconds. That's actually a pretty quick time for 100 meters. I don't, is it that fast? Let's find out. What was that? Oh, wait, what? Okay. Oh, it's question 4. Oh, yeah, it was, okay, wait, they got 12 seconds. Use that? No. They use 9. I'm getting 11.1, which is reasonably close. I mean, in the world of sprinting, I think a 0.9 second difference is quite a lot. Especially if the calculation is correct. That's weird. They're getting 11, but I think the math is correct, so. And they couldn't round up due to significant digits. They wouldn't be able to do that. Oh, but the acceleration's correct. It's probably fine. It's probably fine. Okay, 41. A race car reduces its speed from 20 meters a second and comes to a complete stop after 50 meters. Okay, A, determine the acceleration of the car. So we have a velocity, we have an, I guess, initial velocity of 20 meters a second. And it comes to a complete stop after 50 meters. So we have a displacement of 50 meters. Now we're looking for the acceleration. Now we do have formulas for this. Could simply be a, if we want acceleration, we're probably gonna need the, I think, v2. Yeah, because that gives us the acceleration. So we might have to do, that's v1. Okay, so v2, I think is going to equal, we couldn't do that before. We don't know the time. Do we need to know the time? Let's just try it this way first. We'll see how it goes. So v2 is going to be, I think, yeah, no, I couldn't do it that way. I think it's figure out the time first. Yeah, let's try it. Okay, so we'll say 20 meters a second equals 50 divided by the time, which would be 50 divided by 20 meters a second, will equal 2.5 seconds. With that, can we now find acceleration? So it's going to equal 20 meters a second divided by 2.5. Technically, this would be what? It would be negative because we're decreasing. Acceleration is going to be negative 8 meters a second. idea how you do this question. So I'm gonna draw a picture of this from here. This is all wrong. So from here to here is 50 meters. In this time, a car has reduced its speed from 20 meters a second and comes at a complete stop. So it goes all the way over here and then he stops right here. So he's decelerating in this period and he stops here. Okay. Okay. It was 2.5 seconds. I think our time has to be 2.5 seconds. It has to be. There's no way it's not that long. Time is it? I've been streaming for 46 minutes. Wow, it's crazy. I feel like it would be 8, but it's not 8. It's the 2.5 is the time. Well, I have all the vectors, all the components up here. Really use them. I think there's 8. It's not 8 though. What if V2 is I don't get this question. I don't know. I wish there were solutions to these, but there's not. Like, velocity involves time, which means I have to get the time. Now, to get time, like, do we have a velocity? We have 50 meters a second, which is a... No, we don't. Wait. Alright, yeah, we have 20 meters a second. That's the velocity. So it's 20. Equals displacement. Equals displacement over time. Put some shorts on. It's hot in my room. I can study better now. understand what I'm doing wrong here. Like, we have a big velocity. Could I use any of these equations? Like, if we made v2 that and v1 that, but like it all involves time. It would be v. So v2 be 20 minus 0, so v 0. And then it'd be the time divided by 2.5 the time. So something about our time has to be off. Is it 4? No. So the time was 5 seconds. We could get that. Now, how could I get 5 seconds from these values? Gravity wouldn't be a factor in this. There's only really these. The car reduces its speed from this and comes to a complete stop after this. Well, the acceleration, we need the time. How long did it take to do this? Oh, you know what? Well, I don't know if that would change anything, but if this is V, so this is V1, and V2 equals 0. We could try that and try in this formula, so well, no, we'll say we have that right now. Now we still need time. So what if it was negative 20? It wouldn't really change. It'd still be 2.5, but I don't know. I think I'm just gonna keep off. I genuinely have no idea what that question's on. Like, it wants time in question B, which makes me think I can already solve it. The components it gives you immediately, but like there's no way, surely. We're looking for acceleration. We have those. Oh, actually, maybe this. Okay, maybe this equation. We'll try one more time. We'll say v2 equals v1 plus 2a d. So v2 would be 0. v1 would be 20 squared plus 2a, and then we have 50. So we're going to bring the 20 over, and the 20 squared is 400. So we're going to bring 400 over. It's going to become negative. Then we're going to have 2a, 50. 50 will come over. So negative 400 will divide with 50. That will equal 2a. So we have 400. We get negative 8 equals 2a. And now we're going to bring 2 over. So negative 8 divided by 2 equals a. And this gives us negative 4, which equals a, which I believe it was backwards. So negative 4 would be backwards. The answer was 4 meters per second backwards. Okay, finally got it. Okay, that's good. So therefore, acceleration equals 4 meters a second square and then backwards. Okay, so we didn't actually need time. I was being stupid. But now we have acceleration, and we know our velocity, so it should be fairly straightforward. It should be a simple negative 20, I think. So v2 minus v1 over. So that goes over. It would be v2 minus v1 divided by a. So time is going to equal v2, which is 0, minus 20, or would it be in brackets? No, it'd just be this, 20 meters a second over 4 meters a second squared. So time can't be negative, but it is going to be negative here. We're just going to make it positive though. I'm getting 5 meters a second, or I'm getting 5 seconds. Is that correct? 5. Okay, good. I figured the question out. I'm glad I didn't quite give up on it. It's kind of, yeah, I don't know. I find it confusing sometimes with physics. We have so many equations, and I feel like the application of the equations is difficult because it seems like you can use a lot of different equations to solve one answer, but you can't. You have, there's like, I think sometimes there's multiple you can use, but I think most times I find you can only use one, and I don't really know why that is. Like, I don't really know why I can't use that, like, use the velocity it gave me with the distance it gave me and isolate and find time. I don't know why it doesn't work. It doesn't work, but like I don't really know why. All right, question 42. A bowler releases a ball at a bowling alley with a speed of 5 meters a second. The ball covers the distance of 10 meters to the pin, and the ball covers the distance 10 meters to the pins in 2.2 seconds. So our time is 2.2 seconds. Calculate the acceleration of the ball. So we're trying to find A, and I feel like we were given a lot of things we need for A. We have distance, we have time. We need to use a kinematic equation, I'm going to assume. I think I'm going to use this one. So maybe not that one actually. Is there a... I really don't want to use that equation. So I'm going to use this equation. So V2 squared equals V1 squared plus 2A displacement. So V2, I think, would actually be 5 meters a second. Well, that's the speed is total distance. Whatever. V1 should be 0, I believe, and then 2A, and then we have a thing of 10. So realistically, we're going to have 5 divided by 10, which is what, like 2 point, is it, what would that be, half, 1.5, or 0.5? Yeah, so 0.5, and then we're going to divide that by 2. 0.25, that seems a little too slow to the acceleration, so I assume it's not the acceleration, but I don't know. This is question 42. 0.41 is the acceleration. Interesting. Well, I'm in a decimal. I'm not right, but I'm surprised at that number. So we're probably going to have to use that, which sucks. I don't want to do that. But I'm going to try. I'm going to do it, but I'm going to try. I'm going to do 10. Probably, actually, that one could work too. No, we should have one that I think combines all of the components. I think that's how you know it's going to be correct. So this one combines all of the components. So using V2, which is distance. Yeah, V2 minus 0.5 A, we don't know A. That's going to be 2.2 squared. So I'll give this a shot. So we get 10 equals 11. Alright, 0.5 A, 2.2 squared is 4.84. There we go. So now we have, we'll just take 10 divided by 4.84. We'll get 2.1, we'll say. I guess that will take 2.1 and minus 11 seconds, I guess. That's what it's looking like. Negative 8.9 equals 0.5a, and then I guess we'll divide by 0.5. Yeah, so that's wrong. I did that wrong. Or I don't know. It's wrong. It's wrong. I'm sorry. Okay. See, it never is really as simple as it should be. Oh, my friend, Samuel Evans just texted me. I better respond. This is a good study session. Thanks, pal. Alright, I don't know if, I assume you're watching. Someone's watching. I don't know if it's you. I have 3 people in here. Oh my god, I'm actually famous. This is crazy. Ugh. Alright. I'm doing physics. 3 people. Or Sam is what? Okay, Sam, I'm doing physics. I have a test tomorrow. What are you saying? Is there no? Can you not comment? You can't. You looked in my soul there. I'm sorry. Okay, yeah, we're doing physics. It's bullshit. Well, sometimes it's bullshit. I'm a little confused. 0 minus, no, V2, so it would be, V2 would be the 5. 5 minus, so it should be, that would not. It's just 5 and divided by the time. I feel like that should be our acceleration, but it's not. That's the acceleration. Yeah, like, I don't know. I think they're pulling the numbers out of their ass. I don't know where they're getting them. You guys can't comment. I don't know how to do that. There's color. Color. Oh, I can make black and white. That's sick. I'll do that. I can do like a little Oppenheimer thing. That's kind of cool. I just think I just upload. I don't know. I guess you guys can't comment. It's fine. Uh-oh. Alright. Should be good. Is it? Wait. Oh, I can zoom. Oh. Oh, yeah. Oh, okay. That's cool. Oh. Oh. Wait. Alright, there we go. I don't know. Whatever. It's fine. What is this? I need some water. I'm gonna get some water. I'll be back. 4 people? This is sick. Oh, I still got 4. This is sick. This is sick. Life is at a peak right now. I lost a viewer. I'm upset. I'm gonna kill myself. It feels hard to do this because I see myself there, and it feels gross to just see myself like in the corner of my eye. It's kind of distracting. Also, just I think the idea that people are watching me study, it's kind of weird, but we're just gonna roll with it. We keep doing that. I'm basically torturing myself right now. More. All right. Four. See, why would it be backwards? I don't understand why it would be. Is it like, would it be progressively slowing down? I suppose. It kind of feels similar to this one I did. The one before, we were given a velocity and a distance. And this one we're given a velocity and a distance. And use this equation for it. But now we have time to factor in. Wait, it would be a positive. I guess that would, no, that would be a negative. And then, yeah, so if it was positive, we could make it a, then it could be positive. Right? Let's just draw it out. 10 meters in 5 meters a second. We'll call it the distance of 10 meters, and it takes 2.2 seconds to do that. It's bullshit. 5 people? Oh my. Damn. This is getting so cringe. This is sick though. 5 people. Wow. Like a little party. 4 likes? Man, I'm actually famous. Famous study streamer here. Take a look at this. Cactus. Pretty neat. I lost a viewer. This sucks. I'm being greedy. There's like what was it? Like I think YouTube, it's weird now. Like the streaming, like you have to hit a certain requirement of subscribers to stream on YouTube, and it takes like 24 hours before you can actually stream because they have to like verify your account or something like that, or just like I guess grant you access to streaming. And then once you get it, you're only allowed to I think stream for so long until you reach like a certain amount of subscribers. Like I forget what it was, but there was like it said like it talked about a cap or something, and it said it was my subscribers plus 25 minutes, and gradually the more subscribers I get, the more I can stream, I suppose. And then I think if you reach 1,000 subscribers, you can just have full access to YouTube Shorts, or sorry, YouTube Live. I don't know for sure. It was kind of vague when I read the thing. Alright, this question is, we're gonna come back to that one. It's a bit silly. One stone is dropped from the top of a tall cliff, and a second stone with the same mass is thrown vertically from the same cliff with a velocity of 10 meters a second down. Okay, velocity equals 10 meters a second down. Time is 0.5 seconds. Calculate the distance below the top of the cliff at which the second stone overtakes the first. Oh, jeez. Okay. We're gonna draw a picture of the cliffs. This is the cool cliff. One stone is dropped. So one stone is just dropped. And it, in the same, okay, and then the second stone, the same mass is thrown vertically. Okay, so one of them is thrown upward. So we can probably factor in acceleration because that is gravity. Oh, I have one. No, I have one viewer now. This is Oh, Sam's taking a nap. It's okay. Good night, Sam. Okay, one viewer. I don't know who you are, but I appreciate you. Okay, so this is going down. We're trying to answer what zone overtakes the first. Or tanks. Why would you try sleeping to this? That's funny. I'm gonna look at the sections because it provides the section. I'm gonna see that will help me because these are all 1.2. I think I've got like 3 out of the 5 I've done. Let me see if I can find the section. Learn. Okay, equations of motion. those. Yeah, I do. Do I have... Okay. Three people. Holy. All here to watch me study? Two people. I don't know. There's like one constant person in this, and I don't know who it is, and I feel bad for you because I'm literally studying this. It doesn't get any more enjoyable than it is. Oh, someone left. I feel like I should look over. Oh, someone joined. I feel like I should look over and it should just say 0 people because this is truly boring. But whatever. I appreciate it. Oh, someone sent me a photo. I can't really check it, but I assume it's. I assume you're watching Belly. So, that's nice. Thanks, buddy. Boring. What time is it? Hopefully I have dinner soon. If I have dinner, I'm gonna leave. Will I be back? Maybe. I don't know. Probably. The stream will just be like, you'll just be watching nothing for like 30, 40 minutes. But, yeah, if you want to watch a single one. I understand, like, why, I don't know why this is so confusing. I've been this all unit. It's been super easy. And now, the early units are difficult. I don't believe it. Yeah, let's try different. Let's try 1.3. I was doing 1.3 today, and it was pretty straightforward. 1.2, 1.3. Oh, it's dinner time now. Okay. I'm going to. Here's what I'll try to do. Let's see how this works. This looks awful. Is the camera, like, what does this look like on camera? Oh yeah, it looks like, okay. I guess it kind of worked. I have to write this backwards because, like, it flips it. Eden. So, like, let's say, what time is it? I'll say, like, be back at, like, I don't know, like 8. So. Okay, I'm gonna put this here, and we'll flip this. Oh, not. Yep. Okay. Let's try this because I flipped it. That's stupid. It's not gonna. I don't know how I'm supposed to. I can like break. Goes down. And it goes. What's there? Put it there. Position it like that. Bring the light over. So you can maybe see what it says. Yeah, you can read it. All right, goodbye. Oh shit, it's still going. There's still people watching. Alright. I don't know who's watching this. Oh shit, my table got wrecked. Actually, never mind. It's just on. I actually don't know what that is. I'm so sick of this shit. I got some dessert. I got dark chocolate, blueberries. It's like making homemade Brookside. Why? That was a shit blueberry. These are all shit. They're very mushy. No way, Oppenheimer sound. What is this? Oppenheimer soundtrack loop? I'm gonna play that. I love Oppenheimer. It was a good movie. Also a pretty good book. I think I'm only 200 pages into the book. I don't think it's like a 600-page book, but it's very enjoyable, very interesting. Okay. I always found that the textbook is a little inconsistent to what we learn in class. Or sometimes it just doesn't mention, like I learned today, we were looking at a question where it gave us a velocity and it gave us a direction. And the direction was like, I think it was northeast. And it just said northeast. And usually you would have a direction and then I guess an angle. So it'd be like north 15 degrees east, or something like that. And that would allow you to calculate the x and y components of this triangle, essentially, which could help you calculate like the total displacement or whatever. But it didn't have a middle angle there, and I therefore couldn't solve the x and y components, and I had no idea to do the question, and I felt insane. And I talked to my teacher about it, and apparently if they just have nothing there, it just means it's a 45-degree angle, which I didn't know. So that was good to know. There's kind of other things like that as well, where I think that the textbook, the way it teaches you, the formula they use, I think they're a little different than the ones that we use. Not too different, but I think it's the same. I think it's the same. It's the same formula, just like different, I guess, variables, or like the variables represent the same thing, but they look different, and sometimes it just kind of confuses me. But it's not too big a deal. You just work around it. All right, let's do another question. Let's move on to. Oh yeah, let's try 58. 58 looks fun. There's a little triangle. Resultant displacement. It should be this. Okay, I think I know what I have to do for that. Yep.
Want some warm cherry pie?
No, thank you.
Okay.
I got chocolate in my teeth. I'm looking silly on the stream. Whatever. Okay, so I'm gonna draw a picture of this. 6 meters. I think it was like a few. No, it was. It might have been like 3 weeks ago, or maybe a month ago. I watched Oppenheimer. I think was it 3 times in one weekend. I think it was worth it. I had a good time. It's actually my favorite movie. It's such a fantastic movie. I love it. So interesting. So we want to find this. Don't know the angle. So I need to find this x component, and that really should be it. You know this is 3, so yeah, that's 3. So you're 3 meters, and you're the O and you're the A. So we want the A. Gonna be, oh shit, I skipped really far. We coast 23 times 8. So we get 7. So we'll say 7.4 meters. So now we should be able to solve that. So you can assume that that's also this, and this is also 7.4 meters. This is 3 meters. We need the angle. I don't think so. But okay, well, that's the components. Now total displacement. I guess it's that probably. So 9. So 63.76. 63.76. I'm gonna get 7.98. Or we can just say that's 8 meters. Should be 8 meters. Was that the total displacement though? I don't really. Unless we add both those, which could be 16. I don't really understand what that's showing us exactly. Components should be 7.3 or 7.5 and 3. This was question 58. 7.4, y component 3, sure. 2.9, but we'll say 3. And B 7.9. Okay, I didn't do the what's it called? The angle, so I'll do it now. It's very simple. I'll say tan inverse over the opposite, so 3 over 7.4. Oops. Degrees. I believe that's correct. Okay, they rounded down, which it's fine. They got 21, I got 22. I think it's just a rounding thing. That's why. My disgusting hands. Very small hands as well. Oh, so strong. I actually don't work out. I'm just not sure. I've kind of got back in the gym recently. I used to work out quite a bit, and then it's left, and I'm kind of finding my way back to it being interesting and enjoyable, so that's good, I guess. So 1.4, I'm kind of, okay, that was 1.3. Oh shit, what the fuck did I do? No. No, what did I do? No. Not the awesome music I was listening to. Go that way. There we go. It's weird. It seems like these harder units I can do better at. And they're harder and they're more complex as they are building upon the initial, I guess, chapters or sections of this. And those ones are like one dimensional. Now we're getting like 3-dimensional or 2-dimensional, and it should be complicated or more complicated. But for some reason, it's easier for me. I don't really know why. It makes a turn steadily in 5 seconds so that the velocity is 12 meters a second. Okay, so now we're going this way. We have 12 meters a second. And we need to get, where's my eraser? We need that angle. Is it east north? Oh, no, we know that angle is 25. So here is a x, here is x2, here is y. I should think it's v. Here's y. And we want to determine the average acceleration of the vehicle. So we need time, which is 5 seconds, and we need we need a velocity. So I think we're gonna have to make. I think we're gonna have to add our two x components. We have our y. And make a new triangle. Calculate the hypotenuse of that. That will give us our, I guess, overall velocity. Then we put that into the acceleration equation. Use the time we were given, and that should give us the acceleration. Hopefully. I guess we'll find out. Ooh. I hate these blueberries. They suck. Okay, so A and this is A and H. So cos 25, 12. .8. You could probably round that and say 11 meters a second. Or velocity. Yeah, velocity. Velocity in the y would be sine 25, 12. It's going to equal 5.1 meters a second. So now we have these. So now we're going to add to this 15 meters a second. And that's going to give us 26 meters a second for our x component. And we know that this is east, and this is north. So, make a new triangle. It's going to go 26 meters a second east, And it's going to go 5.1 meters a second north. And we need to calculate this, and we need to find this. Okay. I'm probably going to get off of this live stream, I think at 9, because usually 9 is when I get ready for bed, do some reading. And then I'm probably going to wake up early tomorrow so I can study more. We'll see. Realistically, I'm probably not going to stream in the morning, but maybe I will. 5, because I'll probably go at 5 or 6. That's pretty early. Like, there's no point streaming because no one's going to watch it. Whatever. Okay. Doesn't work. 26.5. That's cutting it very close. That's cutting it very, very close. I'm feeling a little unsure about this now. I just want to get the acceleration. Write it down. Check to see if I'm actually on the right track. I don't want to waste my time if I'm not. This question is 59. Oh boy. Okay. Currently there's a velocity of this, so it goes this way, 15 meters a second. Adjacent, opposite. AH makes coast. 3 people, holy cow. 3, so coast 25 times 12. Yeah, so 11. That should be right. And it goes east-north, so. That should technically be it. Did I do the water right? Slide to the slide. 5.1. It's technically correct. I feel like if a blueberry is the tougher it is, I think the harder it is to push, the more, I think the better it tastes. But I also feel like the turgor pressure has to be high, because I think that's what fruits want. They want to have high turgor pressure because their vacuole, is then like fully expanded. And actually, I don't know if it can burst or not. Like this is a pretty tough blueberry. It's got to have some, some high levels of trigger pressure. So this one's a little soft. It's also bigger though, so that means it would need more trigger pressure. Yeah, shitty one. This one's pretty tough. It's good. The harder they are, the more acidic they are, but I think the acidity makes them taste better. Oh. What is there? 50 west. Wait, hold on. No. Wait, west, north. They're going how? Bullshit. I had to go the opposite. Like, unless they mean negative, but I would be negative. It's not. They're going east and they're going east north. I keep going in one direction, or well, two directions, but in the same quadrant. Oh, why is it so confusing? I don't want to assume that the textbook is wrong, but the data textbooks are wrong fairly regularly. So maybe this one's wrong too. Speaking of data, I miss data management so much. Such a fantastic class. By far the best math I've ever done. It was really enjoyable, really interesting. My teacher, best teacher I've ever had. I miss that class. It's better than functions, that's for sure. Physics. I don't even, it's so dumb. I don't want to do these classes anymore. They suck. They're boring, but they get me to where I want to go. Unless I do bad. If I do bad in them, then there's other ways to achieve what I want to achieve, but it might take a little longer, possibly. I don't know. Let's just move on. I really don't understand how they're going to go west direction. If both go east, it would never be west. They would add. Because if you get your new triangle, it should be that. And you would take that and divide it by the time. 5.3 meters a second. But if they're going west, I can't even begin to imagine what foolery must be going on. I'm gonna have to move on. I don't know. I think they're bullshitting. I usually write my physics stuff on blank paper, which might be a waste because I just throw it out after. But it makes it easier. So blank paper as opposed to line paper for math, it's a lot better. Actually, speaking of math, functions. I had a test today in functions. Did I do good in it? I don't think I did amazing. I think I passed. I don't really care about that class. I want like at least a 75 in it. Maybe, I don't know. Maybe I can do better if I try a little bit more in it. But like the issue with school, I find, is that if I can't see the value in something I'm learning, like I think value. I think I determine value in terms of like how I can use it in the real world. And I don't see that with functions. It's a lot of graphs, a lot of triangles, a lot of bullshit, right? And I just don't know how like little squiggly lines or whatever on a graph can be interpreted into something that's useful that will help me in the real world. That being said, I think Ottawa, which is where I want to go, yeah, I want to go for the Bachelor of Science program. I think their math is reliant on functions, which is concerning, considering I hate it. But I've also heard that most of the time, because I'm going for psychology, most of the time in psychology, you just look at the Bachelor of Science, or you just look at you use data as like the primary math, which makes more sense because it's like, um, well, it's data. It's you collect data and then you interpret the data, you put in data in tables, and that's kind of what you do in psych at some point, I think. So I don't know. It'll be interesting. I will say though, I had all the classes I have right now. So I have bio, physics, and advanced functions. I did I didn't do good in any of them last year. I was a very bad student last year. I've kind of got my shit together this year. I'm doing a lot better. Um, but like this semester is, I think, infinitely harder than my last semester. And there is there's a lot of work to do, and my background knowledge in all the subjects is very poor. So instead of like just kind of like building off of previous knowledge and like going through a little bit of review and just kind of understanding things, I'm basically learning everything for the first time. And it's at accelerated rate now because it's grade 12 level, and they're trying to really they really try to move through that like review period from like last year and then move on to new stuff. And now we're on to new stuff. It's not going terribly. Like bio isn't too bad. Bio like it's like memory based stuff, and I'm actually quite good at memorizing terms and whatnot. So I'm doing fine in bio. Physics, like I don't know. It's math. It's not terrible. Like sometimes it can be a little confusing. Um, like it's not awful. I don't dislike it. But functions is, I think I really feel it the most on there. I have no prior knowledge. I can learn things fairly quickly. Um, but I don't really understand why they're like that or like what it means. I don't know if that makes sense. Like I can look at something and I can figure out what I'm supposed to do with it, which means essentially I can get the mark. For whatever question it is on a test or whatever. I can figure it out. The problem is like I don't know I guess it doesn't really affect me if I get the marks desired, but it kind of upsets me that I don't really know what I'm looking at and what this means in in comparison to everything else. Like I just see it and I just kind of recognize patterns like, oh, I've seen this before. I have to use this formula or whatever, do this to solve it. Yeah, I don't know. It's confusing at times. The application is a little iffy on my end. Like I don't know. It's whatever. I'll figure it out. Hopefully. Man, yeah, this shit sucks. I'm not really doing this physics stuff. The physics test, it actually got split up into two tests now, I guess. Originally it was gonna be one, and it was gonna be tomorrow. But the teacher told us today that if you guys wanted, we can do half of it tomorrow and half of it on Thursday. And I think majority of people voted yes. I think I voted yes. So I guess you get more time to study for that, which is nice. I also have to study for a bio test, which is Thursday. They're really just throwing everything at me, or at my classmates as well. Yeah, it sucks. It's a lot of work, but then we get March break, so that'll be cool. It'll be really fun, I guess. Physics is quite interesting, though. As hard as it is, I do enjoy learning about it. I don't know, it's interesting. Also, I feel like Oppenheimer when I learn about it. But fuck, it can really piss me off. There's been times where I just sit there and, you know, I don't know if this happens to anyone, but when I get angry, I like sweat a little bit. I get really pissed off, and that happens in physics quite a bit. Holy shit, I got 7 viewers. That's crazy. Some people watching this. I appreciate it. Okay, let's do another question. Let's do some random questions. I'm just gonna throw random ones at myself. See if I can solve it. We'll do 68, page 58, question 68. Look at that. Isn't that cool? Okay. Okay, so firefighter aims a hose at an angle of 60 degrees with the horizontal. The water comes out of the hose with a speed of 60 meters a second. Calculate the max height and max height the water can reach. Okay, so I think, fairly straightforward question. I think we're determining the x and y components of this triangle. So it's at an angle with the horizontal of 60 degrees. So it's going to be like that. So 60 degrees, and it goes up at 60 meters a second. We need to calculate the y vector or component and the x component. That's not how you write those. Okay, so d of x looks like an equal. So here's our O, here's our A, here's our H. So we're using AH, which is cos 60 degrees times 60 meters a second, which will give us 30 meters a second. And then we gotta do for the y, which will be sine 60 times 60. Like, the math, it really is straightforward on some of these questions. And then there's other questions which I just don't understand. I just don't get it. And then like I feel like once it's explained to me, it's like really straightforward. But I don't know. Interpreting some of the questions, I think it's just drawing it out. Sometimes it can be a little confusing to draw it out. But whatever. We move. So A is calculate the max height the water can reach, which should be the y. So this should be the max height, I think. Or maybe not actually. Maybe I have to. I really hope I don't have to do that. I'm gonna check the answer. If it's not what this is, I'm gonna have to do what I think I have to do. 58. Oh no. Damn. Wait, what? That doesn't make any sense. 58A. Oh wait, did I convert it to? Oh, that's why. I have 8 viewers. Holy cow! Look at that, actual party in here. Okay, I need distance. I'm in velocities, so I need time. I swear if I need time. I think I need time. I don't really want to solve for time, but I think I have to. Okay, we're going to try this equation out, because I think if I make this equal 0, it should be possible to do. So that's 0. V1. Oh, they don't have acceleration though, so I don't know if I can use that. Unless, what's going up? So acceleration would be negative 9.8 because it's gravity. So that might work. So, okay, we'll give it a shot. We'll see. So V1, I think would be that 60 meters a second. We give our time. We have, it's going to be negative 4.9 because we're dividing gravity by 0.4 times in gravity by 0.5. Yeah, it's going to be negative 4.9 times 2. So with this here, what does this become? Do we need a... No, sure. That'll go over there. That'll go over there. We couldn't do Pythagorean theorem because we don't have the displacement in the y. How do we get max height? There is a way to get max height. Maybe, oh, actually, you know what? I could have it in my notebook. Where's my physics notebook? Okay, here's physics. Let's see if I can find it. I think, because we did it in the lab. This is new stuff, I believe. So here's the lab. So, okay, max height. We used what equation for that? Get rid of this stuff. I'll be right back. I'm gonna put this in the fridge. If anyone leaves, I'm gonna be very upset. Oh gosh. People left. 2 people left. What did I tell you guys? I said don't leave. I'm gonna be upset, and you left. Can't believe it. Betrayed me. I've never been so hurt in my life. Whatever, it's fine. It's their loss, really. They're missing out on one of the most Oh, I gained a person. Thank you, God. This is great. Okay, my pencil fell. Right? It's right here. Oh no. Oh never mind. Here it is. By the way, look at these pencils. Very nice. They're metal. Oh shit, the lead's crushed inside probably. Okay. Yeah, they're metal. Very, very nice. Very nice material. Okay. So max height. Okay. Oh, actually, yes, I knew. Okay, so we have the Vy1, which we just solved for, which is 52 meters a second. Now, if we want to get the max height, we also need to have V2, because the equation we use is Vy2 squared equals Vy1 squared plus 2a and then times the displacement in the y. So that's what we're trying to find. We're trying to find displacement in the y. So Vy2, interesting. Educate you guys. So the velocity in the y in the vertical, when you shoot something, a projectile, and it goes to the top, at the very top of its trajectory, I suppose, its velocity in the vertical component, the vertical area, it's actually zero. It hits zero. So as it goes up, it's slowing down. Really, it's decelerating until it gets to its max height, and then it hits zero at that point, and it goes down. So yeah, so v2 is actually zero, but v1 should be what we calculated, which was 52. And then acceleration should be negative 9.8, and the y. So here's what we have. We'll just multiply our things. 2 times 9.8. So we're going to get 19.6, and then 52. We get 2704. My friend was telling me how you guys can't actually comment, which I don't know why. YouTube it's kind of strange. There's it's like I have to unlock things. Like the more subscribers I get, I think the more perks I unlock with the live streaming, which is very strange. So I don't actually I don't know what that means, but it's possible that it's because oh shit, what did I do? I'm a kid's account. I'm a kid's account? Actually, I do know that. I'm a kid's account. I've tried to switch it multiple times, and it does switch for a moment, then it switches back, so I don't know how I'm supposed to like permanently switch that. Yeah, never mind. So that's why you guys can't comment. It's because I'm a kid's account. Thank you, Sam, for telling me that. I appreciate it. Yeah, I forgot about that. I need to fix that. That's stupid. I don't know why it's like that. I used to have these videos, and I feel like even my younger videos, I swear in them. Who knows? Who knows? Who knows? Okay, anyways, let's progress. Okay, so we have these two values. And I think all we have to do now is isolate them. Right, that's what it should be. So you're supposed to be, you'd also be a negative, and you would be, technically be a positive. We'll make you a negative, it's fine. It's fine. Who cares? So 2704 divided by 19.6, and this gives us 137.9 meters. Now, that seems awfully high. Seems very, very high. 68. Let's make sure this calculation is correct. It should be correct. That one's, yeah, so this one's correct. And that's what I'm getting, but there's no way that's the right answer. Surely not. I don't even know how they're getting that number, because their max height is... What question is this? Oh, shit. Oh, okay. I was looking at... never mind. I was looking at the wrong question. I figured it out. I got it right. Okay, that's good. Jeez. What if that's been the problem the whole time? Every question I messed up on. It wasn't because I messed it up. It's because I was looking at the wrong question and the answers. That's embarrassing. Whatever. It's fine. We got it. Moving on. So that's our that's a vertical. So You shoot it, it's gonna go up to 138 meters. That's its max height. That's cool. Okay, now we get to do the range of it, the horizontal, how far it will go. Now, luckily for the range, we actually have a calculation for that, which is very nice. So I can just type this calculation in. So the range of calculation, dx equals v2 sine 2 over g. This is only when dy equals 0, which it does. dy is 0 because it's not. Yeah, I'd say it's 0. Okay, that's good. So v2. This would be this should be the, I think, 60. So 60 squared. And then in brackets, we're going to do sine, and another bracket, 2, theta, which is actually 60, so there's 60, and then over 9.8. One thing I also find confusing is that sometimes gravity is used negatively, and sometimes it's used as a positive, which I don't really get, because I think most of the time in the context of the question, it's usually a projectile that's going down, which means that gravity should always be negative, but for some reason sometimes it's just not in the equation. I don't know why. I don't think it's supposed to be negative here. But maybe it's because it would give you a negative value, and to simply reverse that, I think you just divide it by -1 or something like that. So it doesn't really matter, but whatever. 2 times 60, and then sine, and we're going to get 0.87 for 9.8. So 0.87 times 3600, and we get 3132 over 9.8. Divide that by 9.8, and we get our final answer of 319.6 meters. Now that seems awfully big in comparison to the y. It might be wrong. Let's see. It's right. Okay, that's good. It's right. Okay. Okay, so this question is done. It's nice. These are very long questions. So there probably won't be as many. I can't imagine there won't be this many on the test, but I don't know. I enjoy them. I think they make the most sense to me out of some of the other stuff. I think like the last 3 things or 4 things you learned in this unit, they all kind of evolve around components, like having a initial velocity at an angle or at a degree in angle, or at some direction, like east 24 degrees north, something like that, right? And that gives you the hypotenuse, and it gives you the angle, and then you just solve the x and y. It's just like, it's very simple, and I feel like the units, they didn't really do too much to like change that. Like we're still, even to this, like even we just learned a unit yesterday, or learned a new thing yesterday, and still we're just calculating like hypotenuses, and then just adding up our components and making new triangles. Like, it's very straightforward. It's enjoyable. I love it, kind of. Okay. Dolphins in the water at angle 6. So that's 1.5. These are 1.5s. Okay, this one has 3. Guys, session, a volleyball player. It's a ball horizontally at a speed of 27 meters a second from a height of 24 meters. The ball travels until it hits the ground. Determine the time the ball is in the air. Okay. Okay, let me probably do that. So we're up here at 2.4 meters and we're hitting a ball horizontally 27 meters a second. The ball travels until it's the ground, so it's going to be somewhere over here, which sort of gives us, this is what we want to, I guess we want to figure out the time and then the distance, and okay, so it shouldn't be too awful. So determine the time. So A is time, it's in the air. Now, there's a way to solve this. What is it? Oh, yes, okay, so now, this is where we would use the equation I was trying to use last time. So it's dy equals v1y times time plus 1/2 acceleration in the y, and then times time squared. Times time, that's crazy. Times time squared. It's a lot of time. Okay, so we'll fill in our values. So this should be 2.4. This will be, what would I need to find? Do I need to find that first? Well, that's a distance. I'm just going to use this because I think it should be fine. This should be negative 4.9 times squared. Okay, so the equation I think is, yeah, so it's going to be 4.9 minus 27 minus 2.4. And this gives us the blueprint, the foundation, the look of a equation that would be substituted into the quadratic formula. So now we will substitute it into the quadratic formula. Okay, so b is going to be 27. Then our b squared is going to be negative 27 squared minus 4.9 times 4.9 negative 2.4. That's going to be divided by 9.8. Okay. So negative 27 squared is 729. 4 times 4.9 times 2.4 is 47.04. 9.8. So now we have this plus this, and that gives us 776.04. 776.04. And that gives us 27. So 27 plus or minus 27, we'll say 0.9 over 9.8. So now we do 27 plus 27.9, divide that by 9.8. And we get 5.6 seconds, which I think should be correct. Let's see, that was this question. This is 74. Question 74. What? Okay, well... Really? How? Huh. What do we use this? We use our Y. Everything here is Y. We don't have the Y. We don't have the angle. So we couldn't exactly... So we're not given a direction, so I feel like I can't calculate the Y velocity. Unless I'm supposed to assume that it's 45 degrees, like it said to do before when you're given a thing, but I don't know. Is there another way to calculate flight? We got 5 likes now. Wow, look at that. There's 6 people watching. Someone hasn't liked, and it's making me upset. I better see one more like, actually. Yeah, I better see one more like. Yeah, almost 3 hours. That's crazy. What time is it? Oh, I got 12 minutes left, and then gonna get ready for bed. The stream's gonna end. I'm so sorry, guys. Don't worry, you'll get to see something very cool at the end of the stream. It's gonna be sick. I actually don't know how well... Actually, no, you'll be able to see it. I'll make sure you can see it. It's gonna be cool. Okay, anyways, this is wrong. This is a problem. Is the calculations correct? Let's make sure. Yep. 7 viewers. Okay, look at that. Going up in the world. Let me square root it. Get 7%, 27.9. That's just not right. It's got to be because of that. But that, like, surely that wouldn't. Surely that wouldn't really affect anything too drastically. This is question 74. Is reading 0.70, which is terribly low. 0.70 seconds. Whoa. What has happened? My live stream, it went from like 3 hours and now it's at 105. What? Huh. That's weird. Oh well. What are we gonna do? Oh. You guys want to see something really cool? It's actually very stupid, but I appreciate it. I appreciate it. Waterloo bucket hat. Yep. They gave this to me for making it into their program. They're like, hey buddy, good job. Here's a hat. And I will gladly say thank you because it actually kind of looks cool in my room. I wouldn't wear it because I don't really wear hats. Oh, Sam, Sam said burn it. Fair enough. Speaking of Sam, actually, I was gonna show you on camera because I like the picture of you, but I assume you don't want that to happen, so I won't. Anyways, yeah, I like it. I think it looks cool, Sam. It's like I said, I never wear it, but I think it looks cool in my room, so I'll take it. I don't really care. Sam doesn't care. Okay, that's okay. I'll show you. I'll show you. Oh gosh, hold on. Oh. Okay. Okay. So apparently, okay. A bit of a problem. My phone is broken. It's like the camera, the I guess the camera that projects like outward, like not the inward camera. It's broken. But only broken in like 0.5. And I guess on live, it's only in 0.5 because I can't zoom in. So that means I can't show anything on the other side of this. You can only see from the inside camera view, which means I'd have to like fully turn this thing to show you, which I'm not gonna do. That's stupid. So that sucks for you. I can see it. But yeah. Anyways, who cares? We move. Okay. I have to work on getting this into like a not kids channel because I'm 19. I'm a little older than a little kid. I can legally drink. Maybe I should have like a drinking stream. Drinking a bottle of vodka while I do homework just to get through it. Because that's how I feel right now. Okay, Sam. I don't like that comment, Sam. If you guys are wondering who Sam is, he's texting me because there's no chat function right now, so he's just messaging me. I have no idea like who's watching this. Like this is actually so cringe. Like who the fuck is looking at me right now? Whatever. I'm so sick of this. I actually have to do some bio studying, so I might as well do that for like the last 10 minutes. I got 6 likes. Oh, let's go. Yo, can we hit a like goal of 7 likes before I get off the stream? Let's get 7 like goal. Okay, these are all part of this unit, and this is like new stuff. Oh, and this. So that's quite a few cue cards. I'm gonna clean up the area just a little bit, just a bit, because I need to. I'm gonna wake up early tomorrow and do some more studying for physics, but we'll call it a night for now because I'm kind of tired of this shit. Alright, put that there. Okay, clean enough. Okay, we're gonna read cue cards because this is how I memorize. I don't write notes in bio, I write cue cards, and then I go home and read them every night. This has nothing on it, this is useless. Alright, phospholipids. Oh, wait, this is old. I can't remember if we did this. No, these are all. Damn, we did this so long ago. It feels like. I think it was actually just last week, but it feels like a month ago we did this. Whatever. Okay, actually, I think it was maybe 2 weeks ago now. I'm not too sure. Anyways, phospholipids, everybody. So, a phospholipid has a phosphate head and 2 fatty acid tails. The phosphate head portion, it is hydrophilic, which means it likes water. The tails, they're hydrophobic. They don't like water. And when you have the phospholipids, they make a bilayer, actually right here. So phospholipid bilayer. I don't know if you guys can see that. I kind of look. That's what it looks like. So you have your head, like the little circles, and the tails, the 2 lines, and basically the outside is hydrophilic, so it likes water, and the inside's hydrophobic, so I guess it's kind of dry in there. Maybe not dry, but like watery substances or liquidy substances have trouble moving through there. So cytoplasm and fluid surround the cells. It is largely water-based. The polar phosphate head face the water, obviously. The phospholipid bilayer continued. The fatty acid tails form a hydrophobic lipid layer in the middle of the membrane. Water and water-soluble substances do not move easily through this middle layer. The membrane can therefore be a barrier or... what is that word? Partition for the cell? Okay, this is proteins in the membrane. I think there's like, what's it? If your carrier protein, your channel protein, and then you have transmembrane protein. Proteins can be a variety of shapes. These can be found attached to the surface, peripheral, or within the membrane, integral. Proteins can also have hydrophobic and hydrophilic regions. Okay, this one you tell me. It's fine. Fluid mosaic model. The membrane is fluid in the sense that that the proteins and phospholipids can move within the membrane. It is a mosaic? Mosaic. I'm gonna Google that. I'm not too good with word pronunciation. It's not my thing. I think it's. I'm gonna say mosaic. That's my guess. Let's see what Google says. Okay, listen up close, guys. Actually, let me pause the music. Okay, listen.
Mosaic.
I don't know if you can hear that. I'm gonna make it louder. Okay, one more time.
Mosaic.
We'll do it slow.
Mosaic.
I was right. I got it right. What can I say? Alright, so it's mosaic. There we go. Okay, so it's a mosaic because the distribution of the molecule is not regular. Oh shit. I got 1 more minute till I'm supposed to get off. It's okay. We'll get through these cards first. Passive transport. Movement of molecules from high to low concentration across membrane. No energy is needed for this movement of molecules with the concentration gradient. That's weird. No energy is needed for this molecule because it moves with the concentration gradient. 3 types are simple diffusion, facilitated transport, and osmosis. Fun fact, I just did a big osmosis lab, and I just submitted it today. It was enjoyable. I actually liked that lab. It was a lab I did today. Actually, I'm gonna post a picture of the lab I did today because I hated it. It was terrible. I never want to do it. I never want to do it again. It was gross. I'll post it on my Instagram. You guys can watch it or look at it if you follow me on Instagram. Which I don't know if you do because I don't know who's watching me. The most basic difference is the presence of ribosomes. So REA is rough endoplasmic reticulum. It has ribosomes. Smooth endoplasmic reticulum has no ribosomes. What is this? Different functions of endoplasmic reticulum. Smooth and rough. Okay. The function of smooth is mobilization of glucose from glycogen, calcium storage, drug detoxification, and synthesis of lipids. Rough endoplasmic reticulum is protein folding, sorting and transporting the proteins outside the cell to their proper destinations. Wow. Difference / function of vacuole and vesicle. Function: the vacuole takes in waste and disposes waste. The vesicle. It move molecules. Move molecules. Secrete substances, digest materials, or regulate the pressure in the cell. The difference is that a vacuole is larger. The vacuole membrane will not attach to the membrane of other cellular organs. Boom. Done. Similarities / differences between chloroplasts and mitochondria. Similar. Both function to generate metabolic energy evolved by endosymbiosis. Contain their own genetic systems and replicate by division. Both have double membranes and their own DNA. Different. Mitochondria capture energy through cellular respiration. Chloroplasts capture light energy. Wow. Simple diffusion through the membrane. Okay, so I'm going to paint a picture for you guys. So, simple diffusion. It transports like very small molecules like O2 or CO2, right? And it goes through the phospholipid bilayer. So let's say that, actually, yeah, I'll just draw it. I'll draw it for us. Okay, so this is the phospholipid bilayer. This is like the bottom of it, or whatever, right? I don't know if you can see that. Okay, you kind of get the idea. So I'll shine the light. Okay, that might look worse. Whatever. Phospholipid bilayer. O2, small molecules. They're able to. What was it? What was it called? I've lost it. What is this called? Yeah, so they're able to diffuse through this phospholipid bilayer. So they just kind of like go into it. They just, do you see it? It just goes through it, just like that, because it's so small. It can just kind of wiggle its way through. So yeah, that's the phospholipid bilayer. Fantastic phospholipid bilayer. So it's the movement of molecules between the phospholipids and can only occur if the molecules are small and nonpolar. Examples are O2 and CO2. Note: molecules move from a high to low concentration and thus no energy is needed. So interesting, simple diffusion, it's kind of like osmosis, except osmosis just moves water, whereas this is moving, I guess, other small molecules. But osmosis will work the exact same way. If the concentration is high or is low inside the cell, then the molecules will just freely move inside. No energy is needed. Now, if it were high inside the cell and molecules had to get in, you'd actually have to go through you have to use a protein, one of the proteins like the channel protein or the carrier protein, and you'd actually have to use ATP. ATP would be used, I guess, as energy to help push it against that concentration gradient to get into the cell. Just a little fun fact for you. Okay, one more, or two more. Facilitated transportation, channel proteins. Some proteins are shaped like channels that act like pores in the membrane. The inner surface of the channel are hydrophilic. This allows water, polar, and charged ions to pass through the membrane. Movement is from high to low concentration. No energy is needed. Yeah, so this is facilitated transport, uses a protein. This one's passive. Then you can also have, this one's not it. Facilitated diffusion, carrier proteins. So this one transports larger and charged molecules. Some proteins are specifically shaped. So the carrier protein will, I don't know if it changes its shape or only targets these molecules with certain shapes, but it's like lock and key, right? The protein has a shape, and the molecule will fall and it will like connect perfectly, right, based on the shape. And so it does this so it can transport specific molecules across the membrane. The molecule interacts with the channel protein and causes it to change shape. So whatever big charged molecule it is, sees the protein, hits protein, and they're like together forever. It's like yin and yang, and then it goes through. Just like that, actually. The molecule is released by the channel protein on the other side of the membrane. The channel protein will then return to its original shape. Boom. Okay, that's it. Those are all the cards. Now, I'm probably going to read it some more, but I'm going to do off stream, I guess. Because I gotta get ready for bed. And I also gotta read my book. Here's the book that we're reading right now. Actually, I'm reading two, but right on the weekends, I read this book. It's called Wonderland. It's by Zoe Stage. What am I? I'm not too far in the book. I just started reading it. So on chapter 9, page 72. Pretty good book. Some spooky stuff is like just starting to happen, but nothing's really happened so far. It's a horror book. I'm enjoying it. I got a message. Read the stream of bedtime story. Oh, okay. What's a bedtime story? I don't know if I'm gonna see if I have like a very short chapter of something I can read. Let's see. I'm gonna read a dinosaur book. I don't know. I don't really think this is gonna have anything. No, this one's too big. I don't even know what this goes. What about this confusing book? This is a Japanese philosophy book. It's very confusing. Mostly because it teaches, the way it teaches philosophy is through comparison. And it's comparing it to Western philosophy. And I don't know Western philosophy, so I had to buy a book on it. I'm not done reading that book yet. So can't really understand it all. Yeah, no, that's terrible. I'm not reading that. What if I read an entire chapter of American Prometheus? I don't know. Okay, I'm gonna read you guys a bedtime story. I'm gonna find a bedtime story. But first, here's what we're gonna do. We'll do this at the end of every stream. Oh shit, my phone's about to die. Wait, has it not been getting charged this entire time? Okay, it doesn't have much left in it. So I'm just gonna you're gonna have to watch me do it. I don't know if you can see that. That says 181. It's a study streak. That means that for 181 days I've consecutively studied, which I think is pretty cool. So it's going up to 182 today. So 182. That's all I wanted you guys to see. Yes, 182. Okay. Now a bedtime story for you guys. Okay. Okay. Okay, I'm gonna read you guys a bedtime story. I apologize if this sucks. I didn't read it. I didn't pre-read it, so it could be bad. A young boy lay sleeping in his bed when he heard footsteps outside his room. He peeked out of his eyes to see what was happening when his door swung open to reveal a murderer carrying corpses of his parents. After slightly propping them up on a chair, he wrote something on the wall in blood of the dead bodies. He then hid under the child's bed. The child got scared beyond belief. He couldn't read the writing on the wall, and he knew the man was under his bed. Like any child, he pretended that he slept through the whole thing and hadn't woken up yet. He lay as still as the bodies, quietly hearing the breaths from under his bed. An hour passed, and his eyes got adjusted to the darkness. He tried making out the words, but it was a struggle. He gasped. When he finally read out the sentence, "I know you're awake," he read as he I know you're awake, he read as he felt something stiff underneath his bed. Okay, we'll do one more. I know you guys like that. We'll do one more. Okay, this one's a bit bigger. I got my first pair of glasses last week. My parents didn't think I needed them at first, but the doctor said that there was something wrong with more than just my eyes. That was apparently pretty common, and I needed specially prescribed glasses for my own good. He said that many people were never given a chance to see the way I would, so I was lucky to get them. I thought he meant cars and fairway words would become less blurry, but over the span of a couple of days, many more things have become more clear. Started seeing creatures in my nightmares all around. I'd never seen them before. Like in the corners of my room and in darkened parking lots, I took my glasses off for the first time today. And let me just say, it's amazing how quickly demons and creatures turn into trees and shadows. I know I'm not just seeing the truth, but I'm a simple person. I'd rather things remain blurry, just the way it did for everyone else. These are not great. These are kind of they're not very scary. Whatever, it's fine. Okay, I'm gonna end the stream. I hope you guys like the bedtime stories. I hope you guys like the stream. I'll probably be doing this again, like every day. I study, which is every day. So I hope you enjoyed it. Everyone have a good day tomorrow. I will see you tomorrow, probably. Goodbye.